Hello students, so this is the second part on the topic laws of motion. Okay, in our last class we were discussing about the basics, so that is what is the meaning of the force and about the Newton's laws of motion, and we were discussing about the linear momentum. Okay, so after that the conservation of linear momentum. Okay, and also we discuss about the impulse. Today we discuss about the equilibrium of particle. Equilibrium of particle. Equilibrium of particle. Okay, see here the word equilibrium. So it indicates the situation of that particle. The situation of that particle. We can say the particle is at equilibrium. The particle is at equilibrium. So equilibrium, the word, it's a situation. Okay, when do you say the body or the particle is at equilibrium? Okay, so I'll give an example. Suppose the body is at rest. Suppose the body is at rest, or the body is under uniform motion. The body is under uniform motion. Uniform motion andre the body should move with uniform velocity or speed. So if these two either rest or uniform motion, then we say the particle is in equilibrium. Okay, so then the basic thing, so why it has to be at rest and why it has to be at uniform motion. So whenever the net force acting on a body, the total force acting on a body is equal to 0. So then the body will be at rest, or that may be under uniform motion. For example, so there is a table, or let it, so there is a particle now, there is a particle, so the total force is acting downward. So this value is F, and equal amount of force is acting in upward direction also. So then I say this particle is in equilibrium. This particle is in equilibrium. I call this is F1 and this is F2. Suppose F1 is equal to F2 in magnitude, and because of direction I write the negative sign. If these two, if F1 is equal and opposite to F2, then say this body is at rest. Okay, what is the total force now? The total force, the net force acting on a body, is equal to F1 plus F2 is equal to 0, because these two forces are equal in magnitude and opposite in direction. For example, this is 10 Newton and this is also 10 Newton. So plus 10 Newton minus 10 Newton, it yields 0. Okay, so this is the condition for the equilibrium of a particle. Okay, so when do you say the particle is at equilibrium? Whenever the net force acting on a body is 0, then we say the particle is in equilibrium. Okay, so this is about the two forces. Suppose there are three forces. Acting on a single particle. This is a particle and a force acting in this direction. I call this F1, and one more force acting in this direction. This is F2. Okay, and the one more force, that is F3. Okay, if the particle is in equilibrium, it has to satisfy condition. So what's that condition? So that is the vector sum of all the forces must be 0. The vector sum of all forces must be 0, like a F1 vector plus F2 vector plus F3 vector is equal to 0. If this condition is satisfied, then we say the particle is in equilibrium. Okay, so is it possible to get the 0 net force here? Yes. So first we should calculate the resultant of these two forces. Okay, then that resultant force plus the third force. Okay, so how do you get the resultant of these two forces? So in the fourth topic you have studied the addition of vectors by the parallelogram method and the triangle method. So here it is better to go through the parallelogram method of vector addition, because F1 and F2 are oriented or started from the same point. They are co-initial vector. So ಇದು ಎಷ್ಟದಲ್ಲ ಇಷ್ಟು ವೆಕ್ಟರ್ ನಾನು ಏನು ಮಾಡ್ತೀನ ಈ ಕಡೆ ಡ್ರಾ ಮಾಡ್ತೇನೆ. ಇದೆಷ್ಟಲ್ಲ ಅಷ್ಟು ಏನು ಮಾಡ್ತೀನ ಈ ಕಡೆ ಡ್ರಾ ಮಾಡ್ತೇನೆ. ಓಕೆ, ಇಟ್ ಫಾರ್ಮ್ಸ್ ಅ parallelogram. Okay, and the diagonal of this parallelogram indicate the resultant of F1 and F2. Okay, so and it's here now these three forces, okay, it will be like this. This is the resultant of those two and this is the third force. So this Fr, so if add to the vector n aita, vector sum Fr aita plus F3 is equal to 0. So then see this diagram, you can write it like a Fr vector is equal to minus of F3 vector, minus of F3 vector. So the resultant of these two forces, which is Fr and the F3, these are equal in magnitude and opposite in direction. Okay, so by this way you can show these three forces, the sum of vector sum of these two forces is equal to 0. So this is the way how to show the particle is in equilibrium. Okay, finally what to conclude as a equilibrium of a particle? Nim conclusion equilibrium of particle antandre. So the particle is said to be in equilibrium, is said to be in equilibrium if the net force, acting on the body, if the net force acting on the body is 0. Okay, if the net force acting on a body is 0, then you say the particle is in equilibrium. Okay, so this is the statement, or you can say the definition of equilibrium of a particle. Okay. Okay, so the next point is common forces in mechanics. Common forces in mechanics. Okay, you know the basic forces of nature. So those are, the first one strong nuclear force, and second one weak nuclear force, and third one is electromagnetic force, and the fourth one, so that is gravitational force. That is gravitational force. Okay, so if you know all these forces except that gradation, remaining all forces are the contact forces. Okay, so say except that gradation, remaining all are contact forces. And suppose there are two bodies. So this is one body lying over another. So this is the first body I call A, and this is second body B. It's having mass m1, it's having the mass m2. Okay, now the force existing between the two surfaces, so this is called the contact force. Okay, so common forces in the mechanics means we study only the contact forces, except that gradation. Now mechanics alli study madbekadre variety of forces study ಮಾಡ್ತೇವೆ. For example, frictional force, viscous force, okay, normal reaction, weight, okay, so and gradation force. Among these all, the gradation is only so the force which may exert even though the particle is not in contact. That gradation force is only due to the mass, even though they are at a finite distance, so they can interact with the other body. Okay, but the viscous force, friction force, normal reaction, so these are the forces exist only when there is a contact between the two bodies. Okay, then how to define a contact force? We can say like the force exerting on a body, due to the contact with other. The force exerting on one body due to the contact with the other. For example, was a force acting on the A body, so that is the force exerted by the B. So when it happens, whenever there is a contact between A body and B body, then only A body gets some force by the B. Okay, and for this force, okay, so this one, and in the contact force there are many types. So we divide that contact force. Some contact force we call it as a normal reaction. For some we call the normal reaction. For some we call the friction. Okay, for some we call the spring force. Okay, and the fourth one, it is about the tension. Okay, 1, 2, 3, 4. So these are the 4 important forces, so which we take as a common forces in mechanics. Let us see one by one. So was a normal reaction. So this is also a type of common force. It's a type of contact force. Okay, normal reaction. See, the body A is lying over the body B. It means the body B is exerting some forces on A. the body B is exerting some forces on A. So for this force we call the weight. So whose value is mass into acceleration due to gravity. Okay, and here the B is exerting some forces on A, on the surface of A. So there is a force between B surface and A surface, B surface and A surface, and the force which is acting normally, by the A. So this is called the normal reaction. This is called normal reaction. So normal reaction exert only when there is a weight. Only when there is a weight, and it is equal and opposite to the weight of that body. That is normal reaction. Okay. Then in other way, how to define the normal reaction? For example, the body is like this. One body is like this. So it is inclined surface, and we kept one more body over that inclined surface. Is it? Okay. So the force which is acting vertically downward. So this is called the weight. Is it? Okay. As a result of that, so there will be a perpendicular force. There will be a normal force perpendicular to the surface. So this is called normal reaction. Okay. So this will be mg cos theta. I'll explain it later. Is it? So like this. So the force which is normal to the surface, so that is called the normal reaction. The word only indicate normal means perpendicular. Reaction means it is a reply of the action. Was the action here? So the force on the A surface is the action, and A surface is giving equal and opposite reaction. Okay. So in a perpendicular direction. That's why its name is normal reaction. Okay, and you can say it as it is perpendicular perpendicular component, or you can say normal, or you can say vertical component is the perpendicular component of contact force. For example, I give one more example here. Okay, so there is a larger body like a table, and there is a small body kept over that table, right? And a force is applied in this direction. Okay, so now the force which is acting in this way, this is called normal reaction. Is it? So this is the applied force, and this is a normal reaction. So this is always perpendicular to the surfaces which are in contact. So normal reaction is always perpendicular to surfaces which are in contact. Okay, is always equal and opposite to the weight. If it is a horizontal surface, if it is an inclined surface, it changes. I'll explain. Okay, and the next point is about the frictional force. The frictional force. Okay, so for this one, so if I divide this as a two component, as a vertical component and as a horizontal component. So vertical component, this is a normal reaction, and the horizontal component, this is called the friction. Okay, friction or frictional force. So you can write friction, or you can also write as frictional force. So ಎರಡು words same meaning. What's a frictional force? So it is a horizontal component. In simple words, it is a horizontal component of the contact force. So ಇದು ಯಾವಾಗಲೂ ಹೆಂಗಿರ್ತದಂದ್ರೆ ಸರ್ಫೇಸ್ ಹೆಂಗಿರ್ತದೋ ಆ ಸರ್ಫೇಸ್ಗೆ ಪ್ಯಾರಲಲ್ ಆಗಿ ಈ ಫೋರ್ಸ್ ಇರ್ತದ. ಯಾವ ಸರ್ಫೇಸು? ದ ಸರ್ಫೇಸ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಈ ಬಾಡಿ ಮೇಲೆ ಹಿಂಗದ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ ಸರ್ಫೇಸ್, ಇದ್ರ ಮೇಲೆ ಈ ಬಾಡಿ ಇಟ್ಟಿದಾರ, ಹೌದಾ? ಇದಕ್ಕೆ ಪ್ಯಾರಲ್ ಆಗಿರ್ಬೇಕು. ವಿಚ್ ಇಸ್ ದ ಕಾಂಟ್ಯಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್? ದಿಸ್ ಇಸ್ ದ ಕಾಂಟ್ಯಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್. ಇದಕ್ಕೆ ಪ್ಯಾರಲ್ ಆಗಿರುತ್ತದ, ದಟ್ ಈಸ್ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. ಓಕೆ, ಇದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರೋದು ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್. ಸೊ ದ ಫೋರ್ಸ್ ವಿಚ್ ಆಲ್ವೇಸ್ acting normally to the surface, so that is called normal reaction. Okay, the surface which is acting parallel to the surfaces in contact, so that is called the frictional force, right? And the third one is about the spring force, very important one. Spring force. Okay, have you seen the spring? ಎಲ್ಲರೂ ಸ್ಪ್ರಿಂಗ್ ಅಂತೂ ನೋಡೇ ಇರ್ತೀರಾ. ಸೊ ಸ್ಪ್ರಿಂಗ್ ಹೆಂಗಿರ್ತದೆ ಇನಿಷಿಯಲಿ ಈ ಥರ ಹಿಂಗೆ Okay, so if I expand that spring, if I expanded that spring, what happens? So if you want to expand that spring, so what's necessary? So we need to apply some external force on the spring so that it can expand. So ಇವಾಗ ಏನು ಮಾಡ್ತೀನ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ. I call this is applied force. We call this as a applied force. So as a result of that, the spring expands. The spring became like this. Okay, so how much expansion? Initially it was like this. ಇಷ್ಟ ಇತ್ತು ಅದರ ಲೆಂತ್, ಇಷ್ಟಿತ್ತು. ಇವಾಗ ಇದ್ರ ಲೆಂತ್ ಇಷ್ಟಾಗಿದೆ. So I call this is our expansion. This value is our expansion. Initial value ಇಷ್ಟಿತ್ತು, ಇದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಇಷ್ಟು ದೊಡ್ಡದಾಯ್ತು ರೀ ಸ್ಪ್ರಿಂಗ್. ಓಕೆ, ಮೊದಲು ಇಷ್ಟಿತ್ತು, ಹಂಗಾರೆ ಎಷ್ಟು ದೊಡ್ಡದಾಯಿತು, ಇಷ್ಟು ಹೆಚ್ಚಿಗೆ ಆಯಿತು. ಇದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ವಿ ಕಾಲ್ ದಿಸ್ ಆಸ್ ಅ ಎಕ್ಸ್ಪಾನ್ಷನ್. We call the expansion, or you can also call it as a displacement. We can call it as a displacement or expansion. Is it clear? Okay, so whenever the force is applied, there will be expansion, and as soon as you remove the external force, it will re-attain its original shape and size. It re-attain its original size. We have studied this thing in the topic mechanical properties of solids as a elastic property. Elastic property ನೀವು ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಾ, ಹೌದಾ? ವಾಪಸ್ ಇದು ಬರ್ತದೆ ಹಿಂಗೆ. ಸೊ ಹಿಂಗೆ ಎಕ್ಸ್ಪಾಂಡ್ ಆಗಿರೋದು ವಾಪಸ್ ಬರಬೇಕಂದ್ರೆ ಸೊ ಏನಾಗಬೇಕಾ? ನಾ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದೆ. ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಆಫ್ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ದೇರ್ ಇಸ್ ಅ ಎಕ್ಸ್ಪಾನ್ಷನ್. ಓಕೆ, ಆ್ಯಂಡ್ as soon as remove the external force, it again comes back to its original size. Again it comes back to its original size. ಓಕೆ, ಈ ಥರ ಎಕ್ಸ್ಪಾಂಡ್ ಆಗ್ಲಾಕ ಬೇಕಾಗಿರೋ ಫೋರ್ಸು ಅಪ್ಲೈಡ್. ಹಂಗಾರೆ ಇದು ವಾಪಸ್ ಬಂತಲ್ಲ ಹಿಂಗೆ, ಈ ವಾಪಸ್ ಬರಲಿಕ್ಕೆ ಏನಾಗಿದೆ ಅಂದರೆ ಸೊ ದೇರ್ ಜನರೇಟೆಡ್ ಆ್ಯನ್ ಇಂಟರ್ನಲ್ ಫೋರ್ಸ್, ಸೊ ವಿಚ್ ಇಸ್ ಕಾಲ್ಡ್ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್, and this is also called the spring force. This is also called as a spring force. Was a spring force? So this is restoring force generated inside the spring by the applied force. So this is called the restoring force, or it is also called restoring force. Okay, restoring force direction ಹೆಂಗಿರ್ತದ? It is opposite to the applied force. ನೀವು ಈ ಡೈರೆಕ್ಷನ್ದಾಗ ಹೇಳಿದ್ರಿ ಅಂದರೆ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಹಿಂಗೆ ಜನರೇಟ್ ಆಗಿರ್ತದ. ಓಕೆ, ನೀವು ಇಲ್ಲಿ ಬಿಟ್ರಾ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ವಾಪಸ್ ಎಳ್ಕೊಂಡು ಬಿಡ್ತಾರೆ ಅದನ್ನ. ಸೊ ದ್ಯಾಟ್ ದ ಸ್ಪ್ರಿಂಗ್ ಅಗೇನ್ ಕಮ್ಸ್ ಟು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್. ಓಕೆ, ಹಂಗಾರೆ ಈ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಬರ್ಲಾಕ ರೀಸನ್ ಯಾರಾದರೂ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್. ಆ ಸ್ಪ್ರಿಂಗ್ ಫೋರ್ಸ್ಗೆ ಇನ್ನೂ ಒಂದು ವರ್ಡ್ ಏನಂತ ಕರಿತೀವಿ ನಾವು? ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಅಂತ ಕರಿತೇವ. Okay, if you apply the more force, there will be more expansion. If there is more expansion, there will be more restoring force. Is it clear? Okay, we concentrate only on the restoring force, which is called the spring force. So the spring force is directly proportional to the displacement. The spring force is directly proportional to displacement. If the applied force is more, the expansion will be more. Expansion is more. If the expansion is more, automatically the spring force or the restoring force will be more. So that's why we say if there is a more expansion, there will be more restoring force or there will be more spring force. Okay, so if I apply the vector notations, so I should mention the sign negative. Why it is negative? Because expansion is in this direction, expansion or displacement is in this direction, but the restoring force is like this. So because of this restoring force, because of this frictional force, it is returning back to its original position. Okay, so F is directly proportional to minus x. Negative sign indicating that displacement or expansion and the spring force are opposite in direction. Okay, so then I want to write the equal sign. I should mention a constant here, k, and this is x. This is minus k x. Okay. Right, so we should read it as spring force is equal to minus k into x. Okay, this is displacement, this is spring force. Where k is where k is spring constant. Where k is spring constant. How to write the k? So you can write the k as the magnitude of force divided by the magnitude of displacement. Magnitude of force divided by magnitude of displacement. K is equal to F divided by x. Negative sign now bit between because k is a scalar quantity and we write it in terms of the magnitudes of those two forces, force and so magnitude of those two vectors. Which are those two vectors? One is force and the other one is displacement. Okay, so that is spring constant. Okay, or sometimes it is called force constant. How to define the spring constant? So this is the total force divided by total displacement. Like I applied 10 Newton force. I applied 10 Newton force in this direction. So how much restoring force may develop? Applied force and restoring force are equal and opposite. If it is a 10 Newton, this is also 10 Newton. So restoring force is 10 Newton divided by how much displacement? I simply said this is 2 meter displacement. 2 meter displacement. What's the value of K? K value is 10 by 2. This is 5 Newton per meter. Then what do you understand? If you want to expand it for 1 meter, you need to apply 5 Newton force. If you want to expand it for 1 meter, you need to apply 5 Newton. That's why the value is 5 Newton per meter. For every 1 meter of expansion, it needs 5 Newton force. Clear ಆಗ್ತದಾ? If you want to take a 3 meter expansion, so you need to apply 15 Newton. If you want to take a 4 meter expansion, you need to apply 20 Newton. Is it clear? So was a spring force and was a spring constant. Okay, once I'll explain the thing. So whenever there is a expansion in the spring, so the expansion is due to applied force. So because of the expansion, there develops an internal force. That internal force is also called as spring force or restoring force. So that spring force or restoring force is is directly proportional to the minus x. I mean, as x is increasing, the F increases. As x less, F restoring force is also less. And the negative sign indicating this displacement and force. If the displacement is in this direction, the restoring force is in this direction. So that negative sign. So to remove the proportionality sign, I introduce a constant here. So this will be minus kx. Then the value of the name of k is spring constant. And how to get the value of k? So just rearrange the terms F divided by x, and I take the magnitude. So k is equal to F by x. So this is all about the spring forces. And also during the compression, the same thing. During the compression, we give the same explanation. So instead of expansion, there is a compression. Compression ಹೆಂಗಾಗ್ತದ? If I applied this direction, if I apply the force in this direction, okay, ಅವಾಗ ಏನಾಗ್ತದ? The spring became like this. Okay, so this is our displacement now. Your displacement ಹಿಂಗಾಗ್ತದ? ಅವಾಗ ಸ್ಪ್ರಿಂಗ್ಗೆ ಒಳಗೆ ಗೊತ್ತ್ರಿ, ಆ ಸ್ಪ್ರಿಂಗ್ ಒಳಗಡೆ ಒಂದು ಫೋರ್ಸ್ ಡೆವಲಪ್ ಆಗ್ತದ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದ್ಯಾಟ್ ಫೋರ್ಸ್, ಸೊ ಆಫ್ಟರ್ ರಿಮೂವಲ್ ಆಫ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್, it brings back to the original position. So the force which is developed inside to get its original position, this is called restoring force, or it is also called spring force. And see the spring force in this direction and the displacement is in this direction. Again the same concept, F is proportional to minus x, and the same concept. Okay, so it may be expansion or compression. So we are discussing the common forces. So in the mechanics, so there will be gradation force or normal reaction or spring force or viscous force or friction force. Like this there are so many forces, except that gravitation, remaining all are contact forces. That's why we have written the headline contact forces. And in the headline of contact force, we discuss the normal reaction, we discuss the friction, we discuss the spring force, and the last one is about the tension. This is tension. So tension means is a form of force, is a form of contact force. Okay, so tension ಯಾವಾಗ ಡೆವಲಪ್ ಆಗ್ತದ? So instead of the spring, so here if we apply, okay, if you suspend a spring to a rigid support and if you apply a heavy body here, so what happens? There will be expansion. There will be expansion like this. Okay, so instead of the spring, if I am using a string, if I am using the string ಅಂದ್ರೆ ಏನು? ಇಟ್ ಒಂದು ದಾರ ಅದ ಅಂತ ಅಂದ್ಕೊಳ್ರಿ, ದಾರ ಅನ್ಕೊಳ್ರಿ, ಹಗ್ಗ ಅನ್ಕೊಳ್ರಿ, ತಂತಿ ಅನ್ಕೊಳ್ರಿ. ಸೊ ಇಟ್ ಮೇ ಬಿ ಅ inextensible thin wire. Okay, so that is or thread. So this is a rigid support and we have suspended a string here. Okay, and if I apply a body, if I apply a weight here, okay, so this will be the downward force, that is mg. Okay, so in this inextensible ಅಂದ್ರೆ ಏನಾಗ್ತದೆ ಮೀನಿಂಗ್? ಎಕ್ಸ್ಟೆಂಡೆಬಲ್ ಅಲ್ಲ, ಎಕ್ಸ್ಟೆನ್ಷನ್ ಆಗಂಗಿಲ್ಲ. ಇಟ್ ಇಸ್ ನಾಟ್ ಅ ಎಲಾಸ್ಟಿಕ್ ಬಾಡಿ, ಸ್ಪ್ರಿಂಗ್ ಥರ ಎಕ್ಸ್ಪಾಂಡ್ ಆಗತ್ತಿಲ್ಲ. ಇಂಥ ಬಾಡಿನಲ್ಲಿ ಈ ಥರ ನೀವು ಕೆಳಗಡೆ ವೇಟ್ ಆಗಿದೆ ಅಂದರೆ, ಸೊ ದೇ ಜನರೇಟ್ಸ್ ಆ್ಯನ್ ಈಕ್ವಲ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್ ಫೋರ್ಸ್ ಇನ್ಸೈಡ್ ದ್ಯಾಟ್ ಸ್ಟ್ರಿಂಗ್. they develops equal and opposite force inside the string. So this is called restoring force. We can call it as a restoring force. The restoring force which is developed in the string, in the inextensible string, so that is called the tension. That is called the tension. So tension or spring force. So both are restoring forces only. So if that restoring force brings back that body to original position, you call it as a spring force. Okay, if that body is inextensible, inelastic, and if you apply some amount of force, so there will be an equivalent opposite force, so that force is called tension. Then how to define the tension? So tension is a type of restoring force. Tension is a type of restoring force developed in inextensible string. ಯಾವುದು ಹಿಗ್ಗೋದಿಲ್ವನೋ ಅಂಥ ದಾರದೊಳಗಡೆ ಜಡಪ್ ಆಗಿರುವಂಥ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ಗೆ ಏನಂತ ಕರೀತಾರ? ಟೆನ್ಷನ್ ಅಂತಾರ. ಹೌದಾ? ದೆನ್ ಹೌ ಟು ರೈಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟಿ? ಐ ರೈಟ್ ದಿಸ್ ಟಿ. ಸೊ ದಿಸ್ ಟಿ is equal to mg. Okay, or you can write t is equal to weight. And if you want to write in vector notation, t is equal to minus w. Okay, t and w are equal and opposite now. Okay, so that's why t is equal to minus w. Tension is a restoring force in an inextensible string. Spring force, this is a restoring force inside the spring. Okay, and the friction, this is the parallel component of contact force. Normal reaction, this is the vertical component of contact force. So this is about the common forces in mechanics. Okay, now we'll study about the friction in detail. Okay, so friction, in some book they have mentioned it as a frictional force. They may mention it as frictional force. Okay, what is a friction or frictional force? Right, so this is the contact force. So this is a component of, and one more, so I explained. So whenever there is a body lying over under, so there is a surfaces which are in contact. Okay, the parallel force, the parallel component of the contact force, the parallel component of contact force which impeding the relative motion, or actual relative motion. So this is called the friction. How to define the friction? Friction is a parallel component of contact force, which opposes the impending relative motion or actual relative motion between two bodies or between two surfaces in contact. So ಏನು ಹಿಂಗಂದ್ರೆ, ಸೊ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಅಂದ್ರೆ ಏನು? ಇಟ್ಸ್ ಅ ಪ್ಯಾರಲಲ್ ಕಾಂಪೊನೆಂಟ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್. ಎಲ್ಲಾದ್ರೂ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇತ್ತಂದ್ರೆ ಬಾಡೀಸ್, ಅದ್ರೊಳಗಡೆ ಪ್ಯಾರಲಲ್ ಕಾಂಪೊನೆಂಟ್ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ ರೀ, ಕಾಂಪೊನೆಂಟ್ಸ್ ಆಫ್ ವೆಕ್ಟರ್ಸ್, ಹಾರಿಜೆಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ಆ್ಯಂಡ್ ವರ್ಟಿಕಲ್ ಕಾಂಪೊನೆಂಟ್. ದ ಹಾರಿಜೆಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ಆಫ್ ದ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಇಸ್ ದ ಫ್ರಿಕ್ಷನ್. ಸೊ ಏನು ಮಾಡ್ತದೆ ರೀ ಆ ಫ್ರಿಕ್ಷನ್? ದಟ್ ಆಲ್ವೇಸ್ ಅಪೋಸಸ್ the impending to the relative motion. Impending to the relative motion ಅಂದ್ರೆ ಏನು? ಸೊ ರಿಲೇಟಿವ್ ಮೋಷನ್ ಅಂದರೆ ಗೊತ್ತಿ ನಮಗೆ. ಸೊ ಇಫ್ there are two bodies like a body, upper is a body, lower is b body, so it is like this. Either a is moving or b is moving or both may move. So this is called relative motion. ಸೊ ರಿಲೇಟಿವ್ ಮೋಷನ್ ಅಂದರೆ ಏನು? ಎರಡು ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರುವಂಥ ಬಾಡಿನಲ್ಲಿ ಮೊದಲನೇ ಬಾಡಿ ಆದರೂ ಮೂವ್ ಆಗ್ತಿರಬೇಕು, ಎರಡನೇ ಬಾಡಿ ರೆಸ್ಟ್ ಇರೋದು, ಅಥವಾ ಮೊದಲನೇ ಬಾಡಿ ರೆಸ್ಟ್ ಇರೋದು, ಎರಡನೇ ಬಾಡಿ ಮೂವ್ ಮಾಡೋದು, ಅವ್ರು ಎರಡು ಮೂವ್ ಆಗ್ತಿರ್ಬೋದು. ಇದಕ್ಕೇನಂತ ಕರೀತಾರ? ರಿಲೇಟಿವ್ ಮೋಷನ್. ದ ಮೋಷನ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಒನ್ ಆ್ಯನದರ್. ಓಕೆ, ತಿಳಿದಲ್ಲ ಇದು? ಸೊ ರಿಲೇಟಿವ್ ಮೋಷನ್ ಅಂದರೆ ಹಿಂಗೈತೆ, ರಿಲೇಟಿವ್ ಮೋಷನನ್ನು ಅಪೋಸ್ ಮಾಡೋ ಫೋರ್ಸ್ ಇದು. ಅಥವಾ ಇಟ್ ಮೇ ಅಪೋಸ್ ದ ಇಂಪೆಂಡಿಂಗ್ ಟು ದ ರಿಲೇಟಿವ್ ಮೋಷನ್. ಇಂಪೆಂಡಿಂಗ್ ಟು ದ ರಿಲೇಟಿವ್ ಮೋಷನ್ ಅಂದ್ರೆ ಏನು? ಸೊ ಟೆಂಡಿಂಗ್ ಟು ದ ರಿಲೇಟಿವ್ ಮೋಷನ್. ಹೆಂಗಂದರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಸೊ there is a body on a particular surface. So you apply some force, say it started to move. It started to move. If I apply enough force, so it may move. If I apply very small amount of force, say the body is not at all moving. So if I apply still more, not moving. So you are applying the force, to move that body, to give the relative motion. Okay, so tending to motion impending to the motion means tending to the motion. Motion actually aglatilla, motion aglaka try ಮಾಡ್ಲಕತ್ತದ. ಸೊ ಮೋಷನ್ ಆಗ್ಲಾಕ ನೀವು ಕೊಡ್ತಾ ಇರೋ ಫೋರ್ಸನ್ನು ಇದು ಅಪೋಸ್ ಮಾಡ್ತಿರ್ತದ. ವಿಚ್ ಒನ್? ದಿಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ವಿಚ್ ಈಸ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಸರ್ಫೇಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ದ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. ದೆನ್ ಹೌ ಟು ಡಿಫೈನ್ ದ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್? ಸೊ ಫ್ರಿಕ್ಷನ್ ಫೋರ್ಸ್ ಈಸ್ ಅ ಹಾರಿಜೆಂಟಲ್ ಕಂಪೋನೆಂಟ್. ಈಗ ಎರಡು ಬಾಡಿ ಇದಾವಂದರೆ ಇದೊಂದು ಬಾಡಿ, ಇಲ್ಲಿ ಈ ಎರಡು ಬಾಡಿ ಇದ್ದ ನಡುವೆ ಏನಾಗಿದೆ, ಹಿಂಗೆ ಡೆವಲಪ್ ಆಗಿರೋ ಫೋರ್ಸು ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್. ಈ ಥರ ಈ ಡೈರೆಕ್ಷನ್ ಆರ್ ಈ ಡೈರೆಕ್ಷನ್, ಈ ಥರ ಹಾರಿಜೆಂಟಲ್ ಆಗಿರೋ ಫೋರ್ಸ್ಗೆ ಏನಂತ ಕರೀತಾರ? ಫ್ರಿಕ್ಷನ್ ಅಂತಾರ. ಇದು ಎಲ್ಲಿರ್ತದ? ಇಫ್ ದೇರ್ ಆರ್ ಟೂ ಸರ್ಫೇಸಸ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ಓಕೆ, ಈ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಏನು ಮಾಡ್ತದೆ ರೀ? ಇಟ್ ಆಲ್ವೇಸ್ ಅಪೋಸ್ ದ ರಿಲೇಟಿವ್ ಮೋಷನ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಐ ಸ್ಟಾರ್ಟೆಡ್ ಟು ಮೂವ್ ದ ಫಸ್ಟ್ ಬಾಡಿ ಓವರ್ ಅಂದರ್. ಸೊ ದೇರ್ ಇಸ್ ಅ ಫ್ರಿಕ್ಷನ್ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದೋಸ್ ಟು. ನಾವೇನಾದರೂ ಒಂದು ರಫ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಹಿಂದೆ ಹಿಂಗೆ ಎಳೆದ್ರಿ ಅಂದರೆ ಸೌಂಡ್ ಬರ್ಲಾಕ್ಕೆ ಚಾಲು ಮಾಡ್ತದಲ್ಲಿ. ದಟ್ ಸೌಂಡ್ ಇಸ್ ಡ್ಯೂ ಟು ದಟ್ ಫ್ರಿಕ್ಷನ್. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಓಕೆ, ಸೊ ಈ ಫ್ರಿಕ್ಷನ್ ಒಳಗೆ ಡೆವಲಪ್ ಆಗಿರೋ ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲೇನು ನೀವು ಬಾಡಿನ ಈ ಕಡೆ ಮೂವ್ ಮಾಡ್ಲಕತ್ತೀರಿ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ ಇಲ್ಲಿ. ಸೊ ಈ ಕಡೆ ಮೂವ್ಮೆಂಟ್ ಮಾಡಕತ್ರ ನೀವು. ಸೊ ಬಾಡಿ ಫ್ರಿಕ್ಷನ್ ಏನಾಗ್ತದೆ, ಅದ್ರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗ್ತಿರ್ತದೆ. ಸೊ ದ್ಯಾಟ್ ಇಟ್ ಅಪೋಸಸ್ ಇಟ್ಸ್ ಮೋಷನ್. ಇಫ್ ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್, suppose it is not at all moving, it opposes the tendency of motion. So this opposing force is called the frictional force or simply friction. Is it clear? So what's the frictional force? So it is a parallel combination of contact force. What it does, ಏನidre effect ಏನು, ಇದರ significance ಏನು? It always opposes. ಏನನ್ನು ಅಪೋಸ್ ಮಾಡ್ತದ? It opposes relative motion or impending the relative motion or tendency of relative motion. ರಿಲೇಟಿವ್ ಮೋಷನನ್ನು ಅಥವಾ ರಿಲೇಟಿವ್ ಮೋಷನ್ ಆಗುವುದನ್ನು ಅಪೋಸ್ ಮಾಡೋದು ಯಾವುದು? ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್. Okay, it exists between the two bodies which are in contact, and it is always in a horizontal direction to that surface. Is it clear? Okay, so we study this friction. Okay, you can note this one. So you are right, friction is a parallel component of contact force which opposes impending to the relative motion or actual relative motion between two bodies in contact. You can note it like this. So ನೀವು pause ಮಾಡ್ರಿ, ಬರ್ಕೋಬಹುದು ಇದನ್ನ. And next one, we studied this friction under two headlines, as a static friction and second one as the kinetic friction, So what it by static friction? Okay, see so there is a larger body and a smaller body is lying over under. Okay, so if I apply some, for example its weight is 50 Newton. Idenri the weight, correct? Okay, so if I apply 5 Newton force, ಇದ್ರ ಮೇಲೆ ಏನಾದರೂ ಇವಾಗ ಈ ಡಸ್ಟರ್ ಇವಾಗ 50 ನ್ಯೂಟನ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಡ್ರಿ. ಇವಾಗ ಇಫ್ ಅಪ್ಲೈ 5 Newton force like this, so there is no motion, but you are applying some force, right? So if I apply 10 Newton, 15 Newton, 20 Newton, up to 50 Newton, so that body not at all moving. The body is not at all moving. So when you apply this force, and the body is still at rest, so as per the Newton's first law, so the body will be at rest until and unless it is compelled by an external force. ಬ್ಯಾರೆಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡೋ ತನಕ ಆ ಬಾಡಿ ಯಾವಾಗಲೂ ಏನಿರ್ತದ, ರೆಸ್ಟ್ ಆಗಿರ್ತದ ಅಂತಂದು ನಮ್ಮ ಕಾನ್ಸೆಪ್ಟ್ ಅದ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇವಾಗ ಯು ಅಪ್ಲೈಯಿಂಗ್ ಸಮ್ ಫೋರ್ಸ್ ಹಿಯರ್, ಬಟ್ ಸ್ಟಿಲ್ ದ ಬಾಡಿ ಇಸ್ ಅಟ್ ರೆಸ್ಟ್. ಹೌದಾ? ಹಂಗಾರೆ ಫೋರ್ಸ್ ಎಲ್ಲಿ ಹೋಯ್ತ್ರಿ? ದ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಈಸ್ ಕ್ಯಾನ್ಸಲ್ಡ್. ದಿಸ್ ಇಸ್ ಕ್ಯಾನ್ಸಲ್ಡ್ ಬೈ ದಿಸ್ ಹಾರಿಜೆಂಟಲ್ ಕಾಂಪೋನೆಂಟ್ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ವಿಚ್ ಇಸ್ ಕಾಲ್ಡ್ ದ ಫ್ರಿಕ್ಷನ್. Okay, so because of this friction the body is not moving even though you are applying the force. Is it clear? Okay, if I apply 10 Newton, so there is no motion. If at 20, 30, 40, so this applied force is exactly counterbalancing. So it is counterbalancing by the frictional force. The applied force is cancelled by that horizontal component of the contact force. So this horizontal component of contact force is called static friction. ಸೊ ಏನು ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡೋದು ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್? ಸೊ So this is the frictional force, is a frictional force which exactly counterbalances the applied force when it is at rest. ಬಾಡಿ ರೆಸ್ಟಲ್ಲಿ ಇದ್ದಾಗ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ನೀವು ಏನು ಕೊಡಾತಿರಲ್ಲ, ಇದು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಲಿಕ್ಕೆ ಇಲ್ಲೊಂದು ಫೋರ್ಸ್ ಡೆವಲಪ್ ಆಗ್ತದ. ಈ ಡೆವಲಪ್ ಆಗಿರೋ ಫೋರ್ಸ್ಗೆ ಏನಂತ ಕರೀತಾರ? ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತಾರ. ಓಕೆ ನೋಡ್ರಿ ಇಲ್ಲಿ, ಈ ಡೆವಲಪ್ ಆಗಿರೋ ಫೋರ್ಸ್ ಎಂಥದ್ದು ಸರ್? ಇದು ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ರೀ. ಯಾವ ಕಾಂಪೋನೆಂಟ್ ಆಗದ? ಹಾರಿಜೆಂಟಲ್ ಕಾಂಪೋನೆಂಟ್ ಆಗದ. ಹಂಗಾರೆ ಅದಕ್ಕೆ ಏನೇನು ಬೇಕಾ? ಫ್ರಿಕ್ಷನ್ ಅನ್ಬೇಕು. ಅಲ್ಲಿ ಫ್ರಿಕ್ಷನ್ ಯಾವಾಗ ಡೆವಲಪ್ ಆಗತ್ತದ ರೀ? ಬಾಡಿ ರೆಸ್ಟಲ್ಲಿದ್ದಾಗ ಡೆವಲಪ್ ಆಗ್ಲತ್ತದ. ಸ್ಟ್ಯಾಟಿಕ್ ಅಂದ್ರೆ ಏನು? ರೆಸ್ಟ್. ಬಾಡಿ ರೆಸ್ಟಲ್ಲಿದ್ದಾಗ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋ ಫ್ರಿಕ್ಷನ್ ಏನಂತ ಕರೀತಾರ? ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ಆರ್ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ರೆಸ್ಟ್ ಫ್ರಿಕ್ಷನ್. ಯು ಕ್ಯಾನ್ ಕಾಲ್ ರೆಸ್ಟ್ ಫ್ರಿಕ್ಷನ್. ಸೊ ರೆಸ್ಟ್ ಅನ್ನೋ ವರ್ಡ್ ಬದಲಿ ಏನು ಮಾಡಿದಾರಲ್ಲೇ? ಸ್ಟ್ಯಾಟಿಕ್ ಅನ್ನೋ ವರ್ಡ್ ಯೂಸ್ ಮಾಡಿದಾರ. ಓಕೆ, ಆ್ಯಂಡ್ ಸಿ ನೌ, ಸೊ ದಿಸ್ ಈಸ್ ದ ಬಾಡಿ ವಿಚ್ ಈಸ್ ರೆಸ್ಟ್ ಆನ್ ದ ರೆಸ್ಟ್ ಓವರ್ ದ ಆ್ಯಂಡರ್ ಬಾಡಿ. ಎ ಬಾಡಿ ಅದ ರೀ, ಇದು ಬಿ ಬಾಡಿ ಮೇಲೆ ರೆಸ್ಟ್ ಅಲ್ಲದ. ಆ್ಯಂಡ್ ವೆನೆವರ್ ದ ಬಾಡಿ ಈಸ್ ಆಟ್ ರೆಸ್ಟ್, ವೆನೆವರ್ ದ ಬಾಡಿ ಈಸ್ ಆಟ್ ರೆಸ್ಟ್, it means the net force must be equal to 0. Okay, how many forces are acting on this body now? The first one is very simple. So it is having a downward force, so that is its weight. So we call this as the weight. Okay, this weight is balanced by the vertical component of that force, contact force, which is called normal reaction. We call it as a normal reaction. So this W is equal to normal reaction magnitude, and they are opposite in direction. Okay, and say these two forces are cancelled, and say there is one more force while applying in horizontal direction, and the body is not at all moving, means this applied force is also cancelling. I call this is applied force FA. So the applied force is balanced by the horizontal component of that contact force. So this is static friction. This is called static friction. And here if I write the vector notation, these two are equal and opposite. The magnitude of applied force is equal to the static friction developed, and it is opposite to that one. And here this friction force is opposing the tendency of motion. ಕೇಳಿರಲಿ, ಸಪೋಸ್ ಇಲ್ಲಿ ಏನಾದರೂ ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಆಗಿತ್ತಂತೇಳಿ, ಫ್ರಿಕ್ಷನ್ ಇಲ್ಲ ಆಗಿತ್ತಾ, 5 ನ್ಯೂಟನ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ದ ಬಾಡಿ ಹ್ಯಾಸ್ ಟು ಮೂವ್. 10 ನ್ಯೂಟನ್ಗೆ ಮೂವ್, 1 ನ್ಯೂಟನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರು ಮೂವ್ ಆಗಲೇಬೇಕಾಗಿತ್ತು. ಯಾವಾಗ ಇಲ್ಲಿ ಏನಾದರೂ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಇಲ್ಲ ಆಗಿತ್ತಾನೆ, ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಎಟ್ ಆಲ್ ಮೂವಿಂಗ್ ಇವನ್ ದೇ ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ಫೋರ್ಸ್, means the applied force is cancelling. The applied force is cancelling by this component even the body is at rest. This component is called friction. The body is at rest, that's why its name become frictional force. Sorry, frictional static friction. We call it as static friction. Okay, so as per the Newton's first law, the body is at rest. It means the sum of all the forces must be 0. So here how many forces are acting? Vector F plus vector N plus vector Fa plus vector Fl is must be 0. Is it? These two forces are equal and opposite, it yields 0, and these two are equal and opposite, it yields 0. 0 plus 0 is 0 only. So this is about the static friction. And see the next question, the static friction on a body is always a constant value. The static friction on a body is always constant value. For example, this body is at rest, I apply some force like a 1 Newton, it is not moving, means this contact force is giving opposition, and this 1 Newton is cancelled. I apply 2 Newton force, I apply 3 Newton force, and all the time the friction force which is developing here, is it constant? No. So the frictional force, that frictional force is directly proportional to the applied force. As applied force increases, the static friction also increases. So ಎಲ್ಲಿ ತನಕ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದ? ಸಿ ಅಪ್ಲೈ 1 Newton force is not moving, 2 Newton not moving, 10 Newton it is not moving, 20 Newton it is not moving, 30, 40, 49.9 Newton it's not at all moving. When 49.9 Newton it's not at all moving. If I apply the 50 Newton, this body started to move. Okay, once the body started to move, can we have the static friction there? No. Static friction andreno, the horizontal contacting force existing between the two surfaces when it is at rest. So when you apply the 50 Newton, it started to move, then you can't say there is a friction, static friction. So that's why it as you increase the FA, the FS go on increasing, and after a particular value, at a particular value, it converts static friction into a kinetic friction. Static friction andre ಏನು? The friction existing on the body when the body is at rest was a kinetic friction. The frictional force existing between the two surfaces when there is a relative motion, either upper body moving or lower body moving, or both may move. Okay, so that is kinetic friction. So hangare static friction elli tanaka irtada? Up to a particular value of applied force there will be static friction. Like I take the 50 is the critical value. 50 ಬಂದ ತಕ್ಷಣ ಬಾಡಿ ಮೂವ್ ಆಗ್ಲಾಕ್ ಚಾಲೂ ಮಾಡಿತು. So the 49.99, so this is the last value of applied force. This is the maximum value of applied force. So if you cross at this, it started to move in this direction even though there is a friction. ಇಲ್ಲಿ ಫ್ರಿಕ್ಷನ್ ಇದ್ರೂ ಇದು ಮೂವ್ ಆಗ್ಲಾಕ್ ಚಾಲೂ ಮಾಡ್ತು. ಅವಾಗ ಏನಾಯ್ತಾ? ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಹೋಗ್ಬಿಡ್ತದ, ಸರಿನಾ? ಸೊ ದೆನ್ ವಿ ಕಾಲ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸ್ಟಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್, the maximum value of static friction. So this is called limiting force of friction. This is called limiting force of friction. Okay, so what's the limiting force of friction? The maximum value of applied force, the maximum applied force beyond which so there vanishes the static friction and appears the kinetic friction. ಗೊತ್ತಾಗ್ಲತ್ತದ? ಓಕೆ, ಸೊ ಆಸ್ ಪರ್ ಅವರ್ ಎಕ್ಸಾಂಪಲ್ 49.99 is our maximum value of static friction. If you cross that 49.99, it changes to 50. 49.9 ಗೆ static, ಇದು kinetic. So this is the maximum value of static friction. So this is called the limiting force of friction. Okay, so symbolically we write it as Fs. Fs means static friction. Fs means static friction, and here I have written as a maximum. So maximum value of static friction is nothing but limiting force of friction is always equal to mu s into n. So you can write it like is always proportional to the n. Is always proportional to the n. Maximum static friction is directly proportional to normal reaction. Okay, I want to write the proportionality sign. So now I will write Fs maximum. I write a constant. For that constant I call mu. How to pronounce it? So you should read it like this one. You should read it as mu. Okay, you should read it as mu. So mu and the subscript s. S is for static. S is for the static. Okay, mu s into n. So it's a very important result. Maximal static friction is equal to mu s into n. So what's the n? N is a normal reaction. This is the n. N is normal reaction. What's the value of n? So that is equal and opposite to the w, that is nothing but mg. And say you have taken only the magnitude, so here you can also write it as mu s m into g. Mu s m into g. Is it right? Okay. So next one, maximum value of Fs is equal to mu s into n. So now I want to write simply Fs. What is Fs? What is the difference between Fs maximum and Fs? Fs means is a static friction in various cases. And what is the F maximum? Is the maximum value of this one. Like this example, as per this example, if I apply 5 Newton, this is Fs. 10 Newton, Fs. 20, 30, 40, 45, 46, 47, all are Fs values. Okay, applied force ge equal and opposite Fs. So if I apply 49.9 Newton, so there will be 49.9 Newton in this direction. This is Fs maximum. Okay, so if you apply 50, so there will be no any static friction, there will be kinetic friction. So 49.99 in this direction, so that is called the Fs maximum. Remaining all values are Fs. Can I write it like this? Fs maximum is equal to or less than, static friction is equal to or less than Fs maximum. Correct alla? Static friction ಇದಕ್ಕಿಂತ ಯಾವಾಗಲೂ ಕಡಿಮೆ ಇರ್ತದ ಅಥವಾ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದಕ್ಕೆ ಈಕ್ವಲ್ ಇರ್ತದ? ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅಂತೂ ಇರಂಗಿಲ್ಲ. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಯ್ತಂದ್ರೆ Fs ಹೋಗ್ಬಿಡ್ತದ, ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಬರಕ್ಕೆ ಚಾಲೂ ಮಾಡಿಬಿಡ್ತದ. Okay, so this will is nothing but mu s into n. So then I can write Fs is lesser or equal to mu s into n. So this is all about the static friction.